A scatter plot is another great way to display some of the data that you may have, or some of the data that you may have collected. Scatter plot, is those graphs that you see where there's some dots, there's points on a coordinate grid. Typically, we're talking about a real-world situation, so we're just talking about the first quadrant, and there might be some points that you're graphing. So a scatter plot shows a relationship between two sets of data. A lot of times we use time in a scatter plot, but not always. The correlation is something that we're going to talk about today, and it describes the type of relationship between the two data sets. So almost like describes the trend of what's happening between the two data sets. And then the line of best fit is a line that we're going to draw in, and we want to draw this line in so that it comes the closest to all of the points on a scatter plot. You don't want to just leave one off, so it may not go through any of the points, it may go through all of the points, but it should be as close to all of the points as possible. And we can use this line of best fit to make predictions in between some of the values. So two sets of data can be graphed, and they may have a relationship. They may have a positive correlation, a negative correlation, or no correlation. Now your plots are blank, so you don't have to draw these perfectly, but draw an example of each one of these. Positive correlation means that both sets of data increase or decrease together. When you think about these points, this point right here, it has a low y value and a low x value. As I go over, my x value increased and so did my y. As I go over even farther, my x value increased more, so did my y even more. So as one increases, the other one is increasing as well. That's a positive correlation. Draw an example of that. You don't have to draw the line in, although you can. The line of best fit is this line right here that they drew in. Everybody might have a slightly different line of best fit, but the important thing is that it's as close to all of the lines as possible. You would not want to draw a line out here like this. That's not close to all of the points. It's close to this one over here, but it's not close to those up there. So we'll get that one out of there. Let's look at the next type. A negative correlation means that one of the data sets increase while the other decreases. Take a look at this first point that I see. It has a low x value, right? This might have an x value of like 1, but it has a really high y value, maybe like 20. And as I go over to other points, my x value increases, but what happened to my y value? It decreased. As I go over to another point, my x value increased some more, my y value decreased. So you can see that the general trend is as x is increasing, y is decreasing. One increases, one decreases. You've also learned slope, so think about it like this. Reading the graph from left to right, it's a positive slope. It's going up towards the right of the graph. Reading the graph from left to right, this one decreases, it goes down. It would be a negative slope. So it's a negative correlation as well. And then if you're graphing two things that really don't seem to be related, it might have no correlation, and maybe there's no pattern that you could see. An example of this might be maybe the number of pets that you have and the number of A's that you have at school. There's probably not a relationship between those things. Whereas the number of hours you study and the number of A's you have in school, that might have a relationship because the more you study, probably the better the grades you're going to have. All right, so draw an example, make sure you fill in the box of each one, and also just to point out that you might see in some books that they will describe it as a strong positive or a weak positive, and it can be stronger by if the points are more in the trend of a line. So these points are almost all in a line. That's a really strong relationship. Whereas these points, it's definitely negative, they're decreasing, but they're a little more spread out. That would be maybe a weaker correlation. You don't have to worry about this strong or weak. I just wanted to show you that you might see it in the future. So let's look at example 1. Complete to determine if the two data sets have a correlation, make a scatter plot and draw a line of best fit. When you look at the table, look and kind of check, okay, what's happening to my x value? So when I look at these values, as I read across, my time is doing what? Well, my time is increasing. So the values for the time are increasing, going from 1 to 2 to 2.5. It doesn't have to be the same scale, but overall, all of these points are increasing. Well, then look at what the distance is doing with that. So as you look at the distance, as the time increases, what does the distance do? Well, it's also increasing as well. Remember, which one is it if they're both increasing? If both data sets are doing the same thing, if they're both increasing together, this is a, fill it in, positive correlation. Look up at your graph examples from above. Now we could also graph this first to decide the correlation. Let's graph these points now. 150, so I'm going over to 1 and up to 50. 2, 150. 2.5, so that's pretty close to that one. It's going to be 175. 4 is 200. And 6 is 270. So we drew a scatter plot. Now we need to draw in a line of best fit. When you draw in your line of best fit, you may want to play around with this and get a ruler. If you don't have a ruler, please use a straight edge of some sort. You can use maybe the edge of your book or the edge of your time tracker or the edge of a folder, but you need a ruler to draw a line of best fit. So don't just draw it in by hand. Get something to make this perfect. Now when you draw in a line of best fit, you may want to line up your ruler and play around with it a little bit first. Let me get my ruler. I would move the ruler so you think it's the closest to all the points. So like if I left the ruler there, is that the closest to all of the points possible? This one's pretty close, these are close, but those are kind of far. All right, we'll turn it some more. If I put it up here, is that the closest that it could be to all of those points? Not up on this edge, but maybe down closer to here. So let's move this down. Move the ruler until you get it really close to all of those points. It can go through some of the points. It doesn't have to go through any of the points. And I also like to look for some balance. So I think, okay, well, this is a pretty good spot because there's 2 dots above it, but there's 3 dots below it. There's 3 points below and 2 above. That's pretty close. And it's really right in the middle of those. You might turn it a little bit more, have it a little closer to those 3, but somewhere in there would be a good spot to draw a line of best fit. Draw that in. Can't tell if that's drawing. And there's my line of best fit. You should put an arrow on this end because we want to show that this trend might continue on, okay? So overall, this has a positive correlation. It's increasing with time and distance. And there's your line of best fit. However you draw it, it should be as close to all of the points as possible. Let's try another one. Let's graph this one first, and then we'll talk about the correlation. Because sometimes the points in the table could be mixed up. I could give them to you in random order. So let's graph this one first. We have make a scatter plot and draw a line of best fit. Costco offers a reduced price when you buy a larger quantity. So if you buy 2 boxes of something, maybe it's cereal, it's going to be about $3.95 per box. Whereas if you buy 10 boxes, they're reducing the price a little bit more for you. You get $3.35. Or sorry, $3.75. If you buy 25 boxes, it's $3.35. If you buy 30 boxes, it's $2.90. And if you buy 43 boxes, it's a weird amount, but it's $2.25. So you can see what's happened to the points here. Without looking at the table, let's decide what kind of correlation this has. Overall, the trend, when you read this graph from left to right, is doing what? It's decreasing. Then there is a negative correlation. If we drew a line, it would have a negative slope. Also, let's look at the points. This point has a low x value and a high y value. As I go over, my x value is increasing, my y value is decreasing. As I go over, my x value increased, my y value decreased. So the boxes is increasing, and the price is decreasing. This is a negative correlation. Let's draw on our line of best fit. Again, it doesn't have to go through any of the points, but it can go through some of them or all of them, but in this case, it's not going to fit through all of them. So I might draw a line and kind of play around with it, drag it around a little. I don't want it like this because these points are really far away. So I need to get it really close to all of the points. I could leave it there, but I think I could make it a little more perfect because these are kind of far. This one's really close. So let's even out that distance here on both sides. Like I said, I also like to take into consideration, well, if I have, 2 points above it, I might want to have close to 2 points below it. Because it's like each one of these points is pulling at your line, and they're all pulling their own weight to get it closer. So somewhere in there should be your line of best fit. I think that looks pretty good. I'll throw an arrow on the end of there. And the nice thing about using these lines is you can then make a prediction for maybe some of the in-between values. So about where the price would be for 17 boxes or about where the price would be for 35 boxes. So it's just nice to use the line to see the trend. Let's practice more with describing the correlation. On the next example, I would like you to describe the correlation between the data set as positive, negative, or no correlation. The increase in temperature and the number of people at Seven Springs Ski Resort. What kind of correlation do you think this would have? Think about the graph. As temperature is increasing, how many people are going to the ski resort? What's happening to that number? Well, if it's a lower temperature, there's probably going to be more people skiing. But as it warms up, the weather's warming up, the snow's melting. There's probably going to be less people at the ski resort, right? So this would be a negative correlation. As one increases, the other decreases. The size of the bag of popcorn and the price of the popcorn. So think about maybe if you're at a movie theater, if you get a small, a medium, or large. As you go up in size, what happens to the cost? It typically goes up, so this would be a positive correlation. Now, it may not go up as much because they want to encourage you to buy the bigger one, right? But overall, your small popcorn is going to be cheaper than your larger popcorn. And the last one, the population of a state and the number of senators. This requires you to have a little bit of social studies knowledge. How many senators does each state have? Well, each state always has 2 senators. So since it always has 2 senators, that's not increasing or decreasing. The population of the state may change, but the senators is always 2. This should be, hopefully you already said it, a no correlation. It's not positive and it's not negative. No matter what the population is, there's always 2. So let's use this last example then to make a prediction. Use the data to predict how much money Taylor would get from babysitting for 7.5 hours. This was like what I was talking about with the graph. We might use a graph to make a prediction. If I want to know about how much 45 boxes would cost, I could trace that up to my line of best fit, and then I could trace that over to figure out what the price would be. It's just an estimation. It's just an approximate answer. It's not going to be perfect, but a line of best fit can help you predict. Sometimes you don't even need a line of best fit. We could just look at the table. So we want to know how much she's going to be making between these 2 amounts. Well, if she's working for 7 hours and she makes $56, and she's working for 8 hours and she makes $64, 7.5 is right in the middle there. You might be thinking you're finding the median or a mean of those 2. That's a great idea. We can find the middle of 56 and 64. When you add those up, or you can just kind of count 56 to 64, there's a difference of 8, so add 4 to the 56. 56 plus 4 means $60. She's probably going to make $60 for babysitting for 7.5 hours. Now you could also look for an equation on this table, and this is what you'll be doing as an algebra student. The number of hours gets me this. How? What's the pattern? What do I do each time to the number of hours? Well, 1 times 8, 2 times 8, 3 times 8. So my equation would be 8 times the number of hours. Then you could plug in 8 times 7.5. So you can use the median, or I'm sorry, you can use the mean. Well, actually, it's the middle, it's the median of those 2. You could also use an equation and write one from the table. Perfect. You're ready to go on to your quick check.